Okay, we'll get into lots of algebra on the next page, but first of all, I just want you to be able to picture some of these. So graph a relation and its inverse. Okay, so these may not all be functions that I give you, just a relationship. Actually, I think they all are. So here's our function. Can you graph the absolute value of x plus 3? Well, that's from your catalog of basic functions. Absolute value of x is just the v with its vertex here at 0, 0. What does the plus 3 do to it? 3 to the left. So let's just graph it using transformations. It's going to start here, and we're just graphing this line with a slope of 1 and a slope of -1. Okay, so there's our function. Is that function one-to-one? I guess, first of all, is that a function, and how do you know? And second of all, if it is a function, is it a one-to-one function, and how do you know? Okay, vertical line test, that's a function. Horizontal line test, that's not one-to-one. So let's just say this. This is not a one-to-one function, but it is a function. Okay, if I'm going to reflect this over the line y equals x, so here is the line y equals x. It's just this straight line with a slope of 1 and a y-intercept of 0. So there is my mirror. So I'm going to take this absolute value function. Oh, I don't have a felt pen in here. Let's see if this works. This absolute value function, and I'm going to take and I'm going to reflect it over that mirror. You picture where it's going to go. Okay. So let's do that. Let's take our key points and graph the inverse. So the inverse, x equals absolute value of y plus 3. Okay, so we're going to take some key points, and let's just list some key points here. So it looks like I've got -10 and is that 7? I've got this point here at -3, 0. And this point here at 7 and 10. Okay, so when I'm taking an inverse, I'm exchanging x and y. So not -10, 7, but x is 7 and y is -10. So this point went down here. Not -3, 0, but x is 0 and y is -3. So this point on the x-axis became this point on the y-axis. So this line moved here. Okay, not 7, 10, but x is 10 and y is 7. So this line moved to there. So there's your inverse, but this inverse is not a function, doesn't pass a vertical line test. So this inverse is not a function. And you can see just visually that if your function won't pass a horizontal line test, when you exchange x and y, your inverse isn't going to pass a vertical line test because the horizontal became the vertical. The vertical became the horizontal. Okay, on this next one, we'll do a little bit more work with it. So graphing a function and its inverse. And in this case, we're going to make our inverse also a function by restricting the domain of the original. Okay, so back to math 11, let's graph x squared plus 2. Parabola opens up, vertex at 0, 2, and a basic pattern. Over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. I'm off the graph already, and here's my sketch of my function. Okay, so we're going to do this one a little bit more particularly. So let's state the domain and the range of our original function. Well, it's a parabola. The domain is all reals, and the vertex at 0, 2 opens up my range y greater than equal to 2. So this is a function, passes a vertical line test, but it is not one-to-one. So when I reflect this over the line y equals x, then I'm going to take this parabola opening up, I'm going to reflect it across that line, and it's going to open sideways. Can you picture it? Okay, so let's take a few key points and let's move them. So this point, x is 0, y is 2, is going to become x is 2, y is 0. This point, x is 1, y is 3, is going to become x is 3, y is 1. At this point, x is, and then we've got symmetry again. X is negative 1, y is 3, is going to become x is positive 3, y is negative 1. 1, 2, x is 2, y is that a 6? Is going to be x is 6, y is 2. X is 6, y is negative 2. So you can see this parabola opening up, opening sideways here. Okay, we just flipped it over. So this, once again, because that's not one-to-one, doesn't pass a horizontal line test, my inverse won't pass a vertical line test, which means my inverse is not a function. Okay, here's our solution. We're going to go back to the original and we're just going to look at part of it. We're going to keep this part one-to-one. By restricting the domain, we're not going to look for x's all reals. We're only going to look at x's greater than or equal to 0. Because if I'm only looking at that green branch, then I do have a function. Where did that green branch go over here? Here's the domain range of the new function. The old range is the new domain, x greater than equal to 2. The old domain is the new range, y greater than equal to 0. Which part of that am I looking at? Only this part where y is greater than 0. So there is the inverse. So it's like you're just looking at the principal root. Okay? Okay, so when we restricted the domain so the function was an inverse, then we're just getting this. And you can see how my pattern for my parabola can be repeated. You notice that here I said over 1, up 1, over 1, up 3. Now I'm saying up 1, over 1, up 1, over 3. I'm just saying it inverse. So here's the domain, x greater than equal to 2, the range, y greater than equal to 0. Okay, let me just give you some vocabulary and algebra to refer back to. So inverse. When you want to take an inverse, instead of saying inverse of y equals x squared plus 2, we say x equals y squared plus 2. Exchanged x and y. Then we take this and solve for y. Just like all algebra, if you're going to take the square root of both sides, you have to isolate it first. So isolate the squared, then take the square root. X minus 2 equals y. So when we've restricted the domain so that our y's have to be greater than 0, I'm not saying plus or minus, I'm only saying plus. Want my y greater than 0. So y equals the square root of x minus 2 is the inverse of this function. We say it this way, and f inverse x is equal to the square root of x minus 2. With a domain x greater than equal to 2 and a range of y greater than equal to 0. It has another inverse. The other inverse can be expressed this way. F inverse x is equal to the negative square root of x minus 2. But for this inverse, the domain is x greater than equal to 2, but the range is y less than 0.